Testing, testing, testing.
It's gonna, yeah.
Testing. All right, so it's 12 o'clock. So let's go ahead and finish up this lesson on vectors so we can move into projectile motion so we can finish up with chapter 3 and we can take the first exam. 1, 2, and 3. Okay? No, not today. All right. All right. So yeah. So let's talk about another example with vectors. Okay. I think I'm recording here. Again, we do the Cartesian coordinate system. That's what we start out with, right? And we're going to talk about, as we typically do, we're going to talk about a flight path, right? Okay. So, a person flying from New York to California, whatever. Okay? So let's say that flight has 2 stops again. So we got 3 legs to the flight. Got 2 stops, so we got 3 legs, right? And so, first leg of the flight, we're going to go, and of course this is east, west, north, and south. And we start from the origin, always, we start from the origin. And we are going to go 440 kilometers southeast, okay? So we left the origin and we went this way. That's the first leg of the flight. And then we stopped in our first, this is our first city 1, okay? All right, after 440 kilometers, and we said we went southeast at an angle of 53 degrees below the horizontal. All right? Following that? Everybody following that? So then we said, okay, then we our next, so after we leave there, we're gonna fly, let's say we're gonna go northeast now. Okay? We're gonna go northeast now, right? And we're gonna go this way, right? And we're gonna do that for 520 kilometers. And we went northeast, right? At an angle. Let me rewrite that because it's kind of. All right. Here is the horizontal, right? Remember I told you about the imaginary coordinate systems? So you can see it. This is the horizontal, right? So if I say I went northeast, right, at an angle of 46 degrees to the horizontal, right? So here we went 53 southeast, then we went 46 northeast. Okay, so this is city one. This is city one right here, right? That's our first stop. Then our second stop will be right here at city two. Right? And then we say, okay, well, at that point we went north. We went straight north, right? Well, now we went straight north for 600 kilometers, right? And right, and we went straight north. So that angle is what? This angle is we went 90 degrees to the horizontal. Right, so if we draw our little fake coordinate system right there, then this will be our 90 factor. Draw that line a little better, a little crooked. That would be our vector, right? 600. Okay? So what we want to know is we want to determine, well, so say for instance, when we left city 2, before we made it to our destination, we crashed. We crashed right here. So I'm back at the airport, and I need to figure out, well, what's the quickest way to get to the crash site? Okay? And so how do I do that? I sum these vectors up. That's how I do that. So I need y'all to tell me how we do that, starting with vector 1. Anybody?
You get the X and Y of all the vectors.
Yes. Which one? Which one is the first one? Which one is vector 1?
The 140.
Okay. So we say, so let's call this one A. And we'll call this one B. We'll call this one C, right? So what you just told me is we're going to get this distance, right? And we call this one what? Resultant. The resultant, right? And we know that the resultant vector, let's call it VR, right? VR is what? What is VR? What is it mathematically? The sum of all of the vectors, right? A plus B plus C. Yes, indeed. So then we start with vector A, right? Vector A. We got an X component and a Y component. What are they? Again, we can draw our thing off to the side. If you have a problem with seeing it here, you can just draw it by itself right here. Right? Now we got vector A by itself. So now we should be able to see the components, right? This is X, this is Y, right? And we say we did it from 53 degrees. So what we got? Got it?
For the X, you do the 440 times cosine.
You sound like you're guessing, though. Why are you guessing that? That was right, but why? Don't guess. I don't want you to guess. I want you to sound confident. That was right. But you sound like you wasn't sure. You just guessed it. Right? Because you got 50-50 chance of getting it right. It's only 2. What about when you got 4? Then your chances of getting it right go down dramatically. Okay? So the cosine is what side? Cosine, what's the definition of cosine? Adjacent side. So what side is adjacent to the angle 53? Is it the X component or the Y component? The X component. That's how you know it's cosine. You don't have to guess. You're still looking a little lost there, all right? I'm just telling you how you got that. That's how you should have got that. All right, you may have memorized it. That's what we can't do. We cannot memorize, y'all. It's not gonna work, because I'm gonna change the angle, and that's gonna go completely out the door. Everything you memorize is gonna go completely out the door. If I just say, instead of taking this angle, we take that angle, then that screws you up completely. So that's why I'm telling you, you have to know. Cosine is the adjacent side. And you have to be able to identify what is the adjacent side, what is the opposite side. Okay? So, cosine is, the X component is what? 440 cosine 53. All right? So, evidently, Y is what? 440 sine. But again, if I change the angle, those two swap. So don't memorize. Understand, you cannot memorize this.
Would it be, is Y gonna be negative?
Yes, because it's going south. Absolutely. We need to recognize that too. We need to look at directions and which direction is it pointing, right? Now we go to B, right? So this is vector A. Okay? Now we can do vector B. Vector B by itself is, right, we take it from right here. That's like going up. That's like going right here, like this, right? If I take this and just move it to the origin, that's what this is. Everybody following up what I did just there? Huh? Okay, good. So now we got what? This one is what, 520? So now we got the 46 angle, right? 46 degrees. Now we got now what are the components of B? You just did it right here. You just did it right here. It's the same thing right here.
520 times cosine 46.
This is hey, I'm gonna call you when I get out at 1. Yeah. All right. said what now? 5,
20
20 times what? And that was the X or Y?
X.
That's the X? Right, so it's, 520
Times cosine of 46.
cosine 46 degrees. That's the X component. And obviously the Y is what? 520 sine of 46 degrees. Now we have the C. Right? What are the C? X and Y on the C.
X, the C is 0.
X is 0.
And the Y should just be
600. Yep. Now what? You just multiply?
Well, not like just multiply, but I'm saying we gotta figure it out, add it up, get the results right.
Okay, go ahead. Tell me what to do next. I'm waiting.
I mean, in your calculator, do 440 cosine 53. You get 264.7.
Okay. 264.7. All right.
For the Y, the answer is negative 351.3.
Okay.
I'm still doing the B.
And so on the exam, right, I might give you that problem in the form of a word problem. Like I just explained it to you. Right? I said we took a trip, right, from destination A, right, to destination D, but we didn't make it. Okay? Plane crashed, and we got right here. So we need to figure out what directions we're gonna give the rescue team to leave the airport, right? So we gotta give them the how far and what else? The direction. So, go ahead, I'm listening.
Alright, so for B, the X should be 361.2.
361.2,
Yes, and the Y should be 374.1.
374.1.
Yes, sir.
All right.
So now we have to add all the X's together and all the Y's
Yes,
together?
yes, 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 yes. Actually, we're not gonna find, let me see, let me make sure we're doing, since we're doing the, we don't need, you don't need to find magnitude actually, because it's, because we're talking about 3 dimensions now, or 3 vectors. So you don't have to find, yeah, you don't have to find the, so what I would say here is, I would say, just give me the resultant vector, which would be this, right? So, and the other ones I've given you like one vector plus the other vector so you can do Pythagorean theorem. This one has 3 vectors, right? So that's why you're not gonna use Pythagorean theorem here, okay? You would only go this far here. Because then if you use Pythagorean theorem is gonna be another dimension. and it ain't gonna make sense. Or it's gonna be some more, it's gonna take more for me to explain it if we go 3 dimensions. That's why I told you in the beginning, we only gonna do 2 dimensions in here. But you could do this, you could still do this stuff without doing Pythagorean theorem. You don't need anything for that. And that's what we just did. We just found the vector, found the components, get the sum. And that's gonna give you this. All right? So that's recorded. So I'm gonna post the recording. Oh, y'all wanna go ahead and get it completed? Y'all, it's up to y'all to do these things, right? So, I mean, if you want me to write it out, it's recorded. I'm gonna post it to the Canvas page, okay? And I would advise you to look at it. I would advise you. But it's up to you what you wanna do. Everything is up to you. It's the beauty of this. Right? So let's keep going. Or we're gonna stop here. We can stop here, because we can stop here and move on to projectile motion. It's up to y'all. Y'all wanna stop here? We can stop here and we're gonna go to projectile motion.
Let's just finish the problem.
All right, good. Go ahead, Carl.
Alright, just make sure, what page are we on?
What?
Page.
Well, it's not really a page, because I just made it up.
Oh, I thought it was.
Yeah. It's similar to page 69. If you look at number 9 on page 69, that's basically it. I just made that up out of my head though, but it's similar to that one,
Okay.
right? You see how, if you look underneath that, you see how they adding those things? You see how they just adding them up, subtracting them, boom, boom, boom? You see that? You see the letters? A, B minus A minus B, 2A minus 3B plus C, right? So if that was the case, right, if I said, well, find 2A plus 3B plus 5C, then what would you do? This just means you do what?
Just multiple.
You just multiplying by these, right? But whenever you add them, you know, you gotta add them as components, okay? But this is like 2 times A x plus AY, right? I'm not gonna give you this though. I'm just gonna give you one like that. So don't even worry about that. That's why I didn't even tell you to look in the book, okay? I'm not gonna give you that, because that's a lot of, that's vector math, okay? And a lot of people get caught up in math and they forget about the reason why we're doing this. The reason why we're doing this is physics, not math, okay? But you can get caught up in math easily. So let's finish this one. I'm waiting for you, go ahead.
Oh, okay. I got the X's and Y's. I just gotta do the, Pythagorean theorem.
No, remember I say, we're not gonna do the Pythagorean theorem on this one because we got 3 vectors. So all we're gonna do here is we're gonna do this.
So we added like all the numbers together?
No, not all of them, right? Remember what we said, right? So yeah, we're gonna get all of the oh yeah, that's what we can do. That's what we can do. My bad. So we can do this, right? We can do VRO x, right? And then do it like that. So VA x plus VBX plus VCX. And that's how we get VRY. Then you add these 3 like this. So you can get the 2 components for your Pythagorean theorem.
Okay, I was making sure I was doing
Yeah.
it right.
So do it like this: VAY plus VBY plus VCY. That's how you do it. Then put it into the Pythagorean theorem. So you get the sum of all of them, so you can get 2 components.
That's what I was doing.
Okay? But I didn't wanna really confuse y'all with all that other stuff. Because we gotta move on. We missed a couple of days. We gotta keep going. But that's how we're gonna do it. So let's keep going. Let's get it. Let's complete it since we're gonna do it that way. Go ahead, Corey. You got it now?
Almost.
Go ahead. Whenever you're ready. Or whoever's ready, whoever got it, then say it. All right. So then let's erase some of this stuff over here. All right? And we're gonna say V, so we're trying to find VR is equal to VRX plus VRY. And VRX is equal to VAX plus VBX plus VCX. VRY is equal to VAY plus VBY plus VCY. You got it now? So nobody else got it. Okay. You say what?
625.9 per acre.
So VRX, all right, is 6 what?
25.9.
.9. Anybody got anything different? Good. How about VY?
622.8.
622.8. Anybody got anything different? Okay. All right. Now we got the X and Y component. Now we can find VR, right?
So now you just
Do the Pythagorean theorem now. Yes. Of the two components, which was VX, VR, I'll be specific, VRX squared plus VRY squared. Get that?
Okay, I got it now. It's 882.96, or like 883 if you use sig figs.
880, you say what? 883?
Yes, sir, 883.
All right, 883 kilometers, right? And what was the direction?
Direction is northeast.
No. We in physics class. We forgot how to do direction. I don't know what we thinking about. There ain't nothing to think about. There's nothing to think about. So I see a lot of long faces.
now we do the inverse of tangent.
Yes, ma'am. We do the inverse tangent of what? Nope. What do we do the inverse tangent of? Y over x. What is y over x?
622.8 over 625.9.
Yep, 622.8 over, let me erase this, y'all. Getting a little messy here. Maybe I'll write it right here. Theta, which is the direction, is equal to inverse tangent y over x, which is equal to inverse tangent, in this case, of what? 622.8 over 625.9. And what's that number?
0.995.
0.995?
I got 44.
You got you might.
That's probably.
Yeah, I got 44.9.
You got what?
44.9.
That sounds better, right? 44.9, right? Now if we look back here, what does this angle look like? Right here. 44.9. Okay? So this stuff, like I told y'all, this stuff has to make sense all the way around. Okay? All these numbers make sense. So we got a final answer of what? 880, you said? 880? 883 kilometers at 44.9 degrees above the horizontal. That's what we're gonna tell the rescue crew. That's what we're gonna give them for directions, right? All right, so again, we're doing all of that to lead up to projectile motion, folks. So that's just the first half of this chapter. So the second half is on the actual projectile motion, right? The actual projectile itself. Okay? So let's jump right into solving some problems with projectiles, because they are they can be challenging if you don't, particularly if you don't practice. They're gonna be challenging. I can guarantee you that. All right. So let's see. Let's see what we're gonna do first. All right. Let's look at number 22. How much time we got? Let's look at number 22 on page 69. 22 on page 69. All right. Football is kicked at the ground level with a speed of 18 meters per second at an angle of 31 degrees to the horizontal. Right? How much later does it hit the ground? Right? So what are we looking for? How much later does it hit the ground? Time, yes. Right. So we're looking for time. Right. And then we're talking about the interval, that's probably gonna be on seconds, right? And 3, so what are the givens here? Right, seconds. What are the givens?
18 meters per second.
So we have a what? We have a speed of 18 meters per second. What else we got? At an angle of 31 degrees. 31 degrees. Right. And so, what equation are we going to use to solve the problem? Do we know? Does anybody know? All right. So we're going to use the constant acceleration equation. We're going to use the constant acceleration equation, right? So in the constant acceleration equation, right? So we can write it in terms of x or y, right? And in this case, we're gonna write it in terms of y, right? So y equals y naught plus v0 and the y times t plus 1/2 gt squared, right? So we can also, and because it says what? It says the ball was, a football was kicked. So we can draw a little diagram if we want to, right? And we can say this is y, this is x, here's the football, this kick, this is our vector v, right? Is 18 meters per second, right? So we can take our components from that. This is our components, right? So if we take our components, then we know that VO in the X is, and this is what? 31 degrees, right? And we know VO in the X is what? What is it? Huh? Huh? No. VO in the X. If VO in the X is 0, it's gonna be sticking straight up. Right? That's the only way it'd be 0 if it's going straight up. I'm telling you so this is, what side is this? To this angle? The adjacent side. So this is cosine then, right? So VO in the X is
18
18,
times
18 cosine 31 degrees. VO and the Y is what? 18 sine 31 degrees. So y'all see what we doing now? So that's the speed of the ball, initial speed of the ball, in the X and in the Y. If I put these two back together, I'm gonna come back with what? Huh? How did we get them? We got these by the Pythagorean theorem. So if I go the other way and I put these back in the Pythagorean theorem, I'm gonna get 18. That's how we got 18, right? Because that's how we got these is from the 18. That's from the Pythagorean theorem. So if I go backwards, if I take these, V, O, and the X, I just told y'all this was this, right? Just told y'all this was V, or R, I had R, right? Is what? RX plus VRY, right? That's what that is, right? That comes from VR squared equals VRX squared plus VRY squared. That's Pythagorean theorem, right? That's where that comes from. So that's where this comes from, okay? If I take these two and put them back here and get the square root, I'm gonna get 18. All right, so now we got an initial speed in the X and an initial speed in the Y. So now we come here, right? Well, we got our, this should be actually 5, right? So when we kick the ground from Y equals 0, and where does the ball land back? If I kick the ball from the ground, land back on the ground. So it's gonna land back at 0. So YO is 0 and Y is 0. Okay? So we can start putting that in, right? So this is our initial speed in the Y direction, which is 18 sine 31. And we're gonna have plus 1/2, let's see, it's negative 9.8. And we're gonna have T here. T squared here. Right? So then, if I take this, so everybody following what we did here, right? This is 18 sine 31 T. Write this clearly so y'all can see it. All right, so this is 18, this is VO and the Y. This right here comes from right there. Sine 31, and this T right here, that's this T. Plus 1/2, gravity is negative 9.8 meters squared, second squared, and then we're gonna have T squared. So now I could just take this, move it to the other side. All right, move that to the other side, that's gonna be what? Negative 18 sine 31 T equals what? 1/2 negative 9.8 meters per second squared, T squared. And of course I can do what now? Not square root, but I got what on both sides? T. So I can get rid of one of them. Right? And so now that leaves me with what? T is equal to 1/2 of negative 4.9. 9.8 is 4.9. So that's gonna leave me with what? T is equal to, and they gonna cancel out eventually. 18 sine 31 divided by negative 4.9. That's gonna give you a positive answer. Because time has to be positive, right? There's no such thing as negative time. If you get a negative time, then you know you did something wrong. So somebody tell me what time we get. Come on, y'all. We run out of time. We run out of time. This is also recorded though, so put both of these on cancel.
I got 1.9.
1.9. That sounds about right. You kick a football, it's gonna stay in there about 2-3 seconds. Yes. All right. So it says 1.9, right? But it says, right? It says, well, that's the how much later. Yeah, that's time, right? So it says, so that answers the question, right? But what if it said, how far does it hit the ground later? Then we know we're looking for what? Distance. So in order to get distance, what do we need?
We need direction.
Nope. Remember from chapter 2. In order to get distance, we only need what? Speed and time. So we already got time. And we got speed. So we can calculate what? Horizontal distance. So here's the time. This is how much later it hits the ground. So if they say, okay, well, at what distance did it cover in that time? Then you would just take the speed and you multiply it times, right? The time. So it'd be what? So we know speed is equal to what? Distance divided by time. So, well, not so, but therefore, x is equal to what? V times t. So V is 18
Meters per second.
cosine, nope, not 18 meters per second. That's the total. That's not the component. Remember what we said? We're in projectile motion now. So we have to break things up into x and y. You always have to do that. See how you went back to that one. That's We're in projectile motion now. So we break that up. We break that up into x and y. That's why we broke it up. That's why we're doing this. That's when we're breaking it up. That's the indication that we're breaking it up into its components. Right? Components means to make up something, right? So the speed here is this, the horizontal speed, x. Horizontal speed. Because here we use the what? We use this as the vertical speed. Right? Yay?
Yeah.
Okay. All right, so 18 cosine of what? 31 degrees times what? 1.9 seconds. And that should give us the distance it covered, which is what?
17.613.
What?
Oh, 17.613 meters.
Meters, yes. 17.61 meters. Okay. All right, so I'm gonna be posting some practice problems on mastering. All right, so hopefully you, if you're not comfortable with that, then you need to come see me in the office hours or send me an email. If I'm not there, sometimes I'm not there. Send me an email, whatever you need to do. We need to sit down for a second and we need to talk about it. All right, because there ain't no getting around it, folks. You got to do it. So yeah, so you can expect to see some problems on mastering physics come up, and that discussion question for chapter 3, and a quiz. You say test? Huh?
Oh, do you know when the test is gonna be yet?
We're gonna do probably next week. We're gonna probably more towards the end of next week. But it's huh? Friday. So you're not planning on being here Wednesday?
No,
You're not
I'm
planning
gonna
on
be
being
here.
Oh, okay.
One day I need to
You
go.
just wanna be. You just wanna know when it is.
I just wanna know cause so I can, put in my system plan.
Huh? Oh.
Oh, my bad.
All right.
I don't think it started recently.
And what happened? What happened? I thought you was gonna come to the outside. No, what?
No, I woke up and then I said, email about them,
But I mean, but yeah, but that's over with now. So
Okay, what's today? Wednesday, tomorrow, what is it? 12?
tomorrow? No, it's not tomorrow. Not tomorrow. Tomorrow is Thursday. So yeah, 10 to 12. Monday, Wednesday,
Okay, so no Tuesday, Thursday.
Friday. Tuesdays.
Just not this Friday. Okay, what
It's on
about,
it's on the canvas page.
okay, what about tomorrow on the lab? They're gonna, is it gonna go over something tomorrow? The lab, or we got something?
I mean, we can go over. Well, we're gonna do a lab tomorrow.
Okay,
Yeah, we're gonna do a lab tomorrow.
alright,
Yeah.
alright, what's today? See you Friday.
All right. Oh, matter of fact, I'm glad you reminded me of that. I gotta call you. Hey, Dr. Yuri, can you get the density lab together for tomorrow? Density. Yes. 1:30. All right, thank you, thank you. Ah. I guess I can turn this off now.
She might be.